fraction. All right, so let's take a look at division. Chris, if you want to pause this video at this point, you can see a problem that we just did here. The answer ended up being A with these restrictions right here. All right, so let's look at division. Copy this one down. X squared minus 3x minus 10 over x squared minus 4x divided by x squared plus 4x plus 4 all over x squared minus 16. All right. There are two extra things we have to do when it's a division problem. What's the first one? Yeah, rewrite it as a multiplication problem. Multiply by the reciprocal. What happens to the first fraction? Stays the same. X squared minus 3x minus 10 over x squared minus 4x. What happens to the second fraction? You multiply by its reciprocal, x squared minus 16 now on top, x squared plus 4x plus 4 now in the denominator. From there, it's pretty much the same as it used to be. We're going to factor. So what does this factor into the first fraction's numerator? Factors of negative 10 that add up to negative 3. Carla. Negative 5 and positive 2. Okay. How about the denominator of that first fraction? Laura. Good. How about the numerator of the second fraction? Megan. Good. Conjugates x minus 4x plus 4. And how about the denominator of the second fraction? Ron? Factors. Yep, x plus 2 and itself. Okay. Remember, though, before we cancel, we need to find restrictions. Where are we going to find restrictions from? Dustin. The denominator. And the numerator of the second fraction. Why? Because at the beginning, this is a denominator. Later, this is a denominator. This has always been a denominator. The only place we don't need to look for restrictions is right here, because this is never a denominator at any time in this problem. But anything that ever is or was a denominator, we must use. So this is the other extra step involved here. You have one extra location to look for restrictions. So I'm looking for restrictions here and here because they are currently denominators, and here because it used to be the denominator originally. Does that make sense? So what are my restrictions going to be here? What is x not allowed to equal for this problem? Cameron. 4. What else? Negative 4. What else? Kyle. Negative 2. What else? Anthony. 0. Anything else? 2. I think 2 is okay. Why is 2 okay? Because I don't have an x minus 2 anywhere. Do I? These are both x plus 2s. Okay. So this one says x can't equal 0, x cannot equal 4. These both give me x cannot equal negative 2. Here's another x cannot equal 4, and here's an x cannot equal negative 4. So I think that's 4 restrictions we have, right? Now, can I cancel anything? Cameron. The x plus 2, one of them. Okay, what else? Laura? An x minus 4 will cancel. What else? That's it. So final answer, what's left? There's an x minus 5 and an x plus 4 still left in the numerator. There's an x and an x plus 2 left in the denominator with all of these restrictions. Well, you could, but again, we're leaving these in factored form. If you want to multiply that back out, you can, but don't make extra work for yourself. Questions on division. You have to flip it, the second fraction, and you have to look at one extra location for restrictions.